Geobyte.
Look at the another important problem. Try to read it clearly. It is asking like this. A body of mass 50 kg is lifted to a height 20 meters from the ground in the two different ways as shown in the figures. Look at the case 1 where the weight is vertically lifted. Okay. And in the case 2, the body or weight is lifting along the plane or along the ramp. Okay. But look at the vertical distance. The vertical distance traveled by the body against the gravity remaining same. Okay. Then the ratio of work done against the gravity in both the respective cases. The work done against the gravity is depending on only vertical distance traveled by the body. Since the vertical distance traveled by the body in both cases remaining same, I can say that W1 by let W1 be the work interaction with the first case, W2 with the work interaction with the second case, W1 by W2 is 1 only, or W1 is to W2 is equal to 1 is to 1 only. 1 is to 1 only. Therefore, option D is absolutely correct. Understood clearly? Yes. Let me write that point. Work work done against gravity gravity completely completely depending on the vertical distance or displacement, vertical distance traveled by the body. Since the vertical distance traveled by the body in both cases remaining same, work done remains same. That is that is work done work done against gravity or under gravity is not depending on is not depending on is not depending on path followed by the object, path followed by the body. I hope all of you clearly understood. Okay, then look at the another important question. Try to read this question clearly. A body of mass m kg slides from rest along the curve of a vertical circle from point A to point B in frictionless path. That means friction effect equal to 0. That's the one condition. Friction effect equal to 0. And at A, the body is at rest. That means initial velocity of the body at A equal to 0. That's another condition. Then the velocity of the body at B. You're asked to decide what is the velocity of the body at B. The body is moving down. It is clearly given. A body of mass mkg slides from rest along the curve of a vertical circle from the point A to point B. Right? You know, this is the vertical distance traveled by the body. That vertical distance traveled by the body, I can say that this is the radius. Let this is the radius r. Then if I project a vertical line from A, let this is the K. Look at the right angle triangle. Look at the right angle triangle. This is given 45 degrees. This is AK, and this is the radius. Then tan tan 45 degrees is equal to tan 45 degree tan let us write the tan 45. I want to AK distance. For that, let us take the sine 45 degrees is equal to opposite side AK by hypotenuse AO, that is R. From this, the AK equal to R sine 45. Sine 45. So R by root 2. So AK distance is R by root 2. Therefore, this H equal to what? R plus R by root 2. Then what you are asked to decide? The velocity of the body at B. For deciding the velocity of the body at B, let us connect the what work energy theorem. Let me write that one. According to work energy theorem, according to work energy theorem, by the time the body is moving down, its potential energy is decreasing. With respect to B, right? With respect to B, potential energy at B equal to 0. Potential energy at B equal to 0 because that is the reference point. That means I can say that according to work energy theorem, potential energy at A minus potential energy at B must be equal to. That means potential energy of the body is decreasing. The drop of potential energy must be converted to other form of energy, that is kinetic energy. That is kinetic energy at B minus kinetic energy at A. That is the law of conservation of energy or work energy theorem. Potential energy at A, but potential energy at B is 0. That point already we have decided. Potential energy at B is 0. Potential energy at B is 0. And kinetic energy at A is 0 because the velocity at A is 0. So therefore, I can say that the potential energy at A must be equal to kinetic energy of the body at B. Potential energy A equal to M into G into H is equal to kinetic energy half into M into VB square. VB square. So here M into G into H value. Already you got the H value. H value is R plus R by root 2. This is the root 2. Should be very careful. R plus R by root 2. It is R plus R by root 2 is equal to half into M into VB square. This M value is cancelling. Finally, I can write that VB square equal to 2 into G into, let us write R outside, 1 plus 1 by root 2. So this is the VB square. VB square equal to 2 into. Look at the G value. G value is given 10. R value 14 meters. Root 2 value 1.4. G value given 10. R value 14 meters. Into 1 plus 1 by root 2 value given 1 point. Root 2 value 1.4. 1.4. 1.4. Listen carefully. Therefore, velocity at B equal to root over 20. 20 into 14, 280. 280 into 1 plus 1 by 1.4. You simplify this value for getting, for getting the answer around, the answer is around 21.9. You simplify this value for getting approximately 21.9 meter per second. That is the velocity of the body at B. So 21.9 meter per second. Option D is absolutely correct. Are you following clearly? I am trying to explain the each and every point for your better understanding. Okay. Similarly, let us take the another important question. Try to read that question clearly. If a rubber ball falls from a height h and rebounds up to the height of h by 2, the percentage loss of total energy of the initial system as well as the velocity of the ball before it strikes the ground respectively. Here a rubber ball is right dropping from a particular height h and it is rebounding to h by 2. Then velocity velocity of ball just before just before striking the ground striking the ground, let that is v1 is equal to root under 2gh. Okay, next velocity of the velocity of ball just after just after striking the ground striking the ground, let that is v2 is equal to root over 2g, right? The rebouncing height is h by 2 h by 2. Of course this 2 cancelling, gh it is gh. Then he is asking the velocity of the ball before it strikes the ground. Velocity of the ball just before striking the ground is root 2gh. Root 2gh. Root 2gh. Therefore, options may be either A or C. B is ruled out. Right? Ruled out. D also ruled out. For that, you need to decide the percentage loss in total energy. It means indirectly percentage loss in total energy means kinetic energy, because nothing is spoken regarding the other energies. Percentage loss in kinetic energy equal to kinetic energy before striking minus kinetic energy after striking dividing by kinetic energy for striking into 100. This is half m into v1 square minus half m v2 square divided by half m v1 square multiplied by 100. Half m part is cancelling. Finally, it is equal to v1 square minus v2 square divided by v1 square into 100. Look at the v1 value. Here v1 value is root 2gh. Therefore, v1 square equal to 2gh. Similarly, v2 square equal to gh. So, in the place of v1 square, write the 2gh. v2 square equal to gh. It is 2gh minus gh divided by 2gh into 100. It is equal to 2gh minus gh. gh by 2gh into 100. It is equal to 50%. The percentage loss of total energy is 50%. Look at the options. 50% to 2gh. Option A is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. Try to read it clearly. Asking like this. A body of mass 2 kg begins to move under the action of a time dependent force given by force is given in terms of time. That means force is acting right on the body which is depending on the time factor. It is given as 60 I cap plus 60 square j cap. The force value is given in newtons. The power developed by the force at the time t is given by. You are asked to decide the power developed by the force. Okay. For that, as you know, the power p equal to force multiplied by the velocity. Force multiplied by the velocity. Force is known. We need to find the velocity. For finding the velocity, as you know, the force F equal to force F equal to ma, then acceleration equal to force by mass. What is the mass given? Given mass is 2 kilograms. Force is 60 I cap plus 60 square j cap, dividing by mass is 2. Therefore, the acceleration equal to 3t I cap plus 3t square j cap. That is the acceleration. From that acceleration, I can find the velocity. Acceleration I got is 3t I cap plus 3t square j cap. That is a cross check it. Absolutely correct. But acceleration equal to what? dv by dt equal to 3t I cap plus 3t square j cap. From this dv equal to 3t I cap plus 3t square j cap, 3t square j cap multiplied by dt. Now upon integration, it is giving v or v bar I can say equal to 3 t square by 2 I cap plus 3 t cube by 3 j cap. It is equal to 3 by 2 t square I cap plus t cube j cap. That is the velocity, maybe in meter per second. Then the power P equal to product of force and velocity. Force, what is the force value? Force value is 60 I cap plus 60 square j cap. 60 I cap plus 60 square. Otherwise, take minute. Let us write right on the downside. Power P equal to power, take minute. Power P equal to force 60 I cap plus 60 square j cap multiplied by velocity. The velocity is 3 by 2 t square I cap plus t cube j cap. Multiply I cap with I cap, j cap with j cap. Here 60 multiplied by 3 by 2 t square. 60 multiplied by 3 by 2 t square I cap plus 60 square into t cube j cap. Here it is 2 3 times. 3 into 3 9 9 t cube I cap plus 6 6, here it is 6 t power 5 j cap. So finally power P equal to 9 t cube plus 6 t power 5. That is the power. 9 t cube plus 6 t power 5. 9 t cube, 9 t cube, 6 t power 5. एक minute. It is 60 square, 60 power 9 t cube, 6 t power 5. 9 t cube, 6 t power 5. Let us write 9 t cube plus 6 t power 5. 60 power 5. Option D may be printing mistake. If I take the option D, 9 t cube plus 60 power 5, D can be selected. Maybe printing mistake. Understood clearly? Yes.
Geobyte.